All right. So last class we saw one application of our sum and difference identities was to evaluate certain uh, sine, cos, tan of certain angles. Another use is finding exact values of angles that are not on the unit circle. Okay. So this is another use of those sum and difference identities. The first one, sine of pi on 12. Well, pi on 12 is not on the unit circle anywhere, right? But we want the exact value, which means we want the answer as expressed as an exact value. It can't be a decimal. We can certainly use our calculator to find out what it is as a decimal. We just have to make sure we're in the right mode. In this case, we'd have to be in radians because pi on 12 is an angle in radians. So the sine of pi on 12 is that. But that's not an exact value. That's an irrational number. It's have to be rounded at some point. But as I said, we can use our sum and difference identities in order to answer these questions. So what we need to do is we need to think about two angles that in this case would subtract to 1 pi on 12, and both of those angles have to be on the unit circle. So only specific angles will work. For example, you would not be able to do, let's say, 5 pi on 12 minus 4 pi on 12. You could not use those two angles because 5 pi on 12 is not on the unit circle. 4 pi on 12 actually is, though, because you can reduce that to be pi on 3. 4 pi on 12 reduces to pi on 3, and that is on the unit circle. But 5 pi on 12 is not. So you need to use two angles that are on the unit circle. So, and often there's more than one set will work, but one set that will work here, I believe, is 4 pi on 12 take away 3 pi on 12. That will work because 4 pi on 12 reduces to pi on 3, which is on the unit circle, and 3 pi on 12 reduces to pi on 4, also on the unit circle. So now we can evaluate this using the difference identity for sine. The sine of A minus B is sine A cos B minus cos A sine B. That is the difference identity for sine that's on the formula sheet. So you don't have to memorize it. It's there for you. Just got to know how and when to use it. So we can get these values off the unit circle. We want to look at angles pi on 3 and pi on 4. So pi on 4 is there. Pi on 3 is up there. The coordinates at pi on 4 are both root 2 over 2. At pi on 3, it's 1/2, comma, root 3 over 2. And remember, you can get these from that hand trick. Remember, all the coordinates have denominators of 2, so at pi on 4, you put down the middle finger. It's just the root of this many fingers over 2, comma, the root of this many fingers over 2. So that's our root 2 on 2, comma, root 2 on 2. And at pi on 3, put down that finger. It's the root of this many fingers, root of 1, which is 1 over 2, comma, root 3 over 2. So now we can get all these values. The sine of pi on 3, remember sine is the y value. The sine of pi on 3 is root 3 over 2 times the cosine of pi on 4, which is root 2 over 2, minus cos of pi on 3 is 1/2 times the sine of pi on 4, root 2 over 2. So this gives us root 6 over 4 take away root 2 over 4, which is root 6 take away root 2 all over 4. There's a common denominator there. So we can combine them. There's our answer. That is the exact value for the sine of pi on 12. When we did it in our calculator, we got our answer as an irrational number, a decimal. Well, we'll take the answer that we just got and check. It should be equal to that decimal. We have to put our numerator in brackets. So it's the root of 6, take away the root of 2, on top, all divided by 4, same decimal. You should never get these wrong because you can check them. You can find out what the sign of pi on 12 is in the calculator, compare the answer that we got, they're the same decimal. So it checks. All right? Question B, what about the tangent of 105 degrees? Yeah. 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 So it says chapter review, questions, page 66.
But the question they have is that the whole page is questions, or do you yeah, I guess.
Yeah.
But then at this part, I'm like, well, yeah, questions are
What are these ones? But if you look on page 66, yeah, maybe they're the same questions. I don't know. Yeah, we can answer. Yeah, just leave them. Okay, sorry. Okay, tangent of 105 degrees. So again, 105 degrees is not on the unit circle. So we need to find two angles that are on the unit circle that either add or subtract, in this case, to get 105. And one set of angles that'll work would be 60 and 45 degrees. They add together to get 105, and they are both on the unit circle. So now we got to use the sum identity for tangent. The tan of A plus B is tan of A plus the tan of B all over 1 minus tan A times tan B. That's on the formula sheet. Now 45 degrees is the same as pi on 4. 60 degrees is the same as pi on 3. So we already have those up above there. We just need to write our tangent values. Tangent is sine divided by cos. The tangent of 45 is 1 because you're dividing something by itself. And the tangent of 60 degrees is root 3. We've done that before. So, tan of 60 is root 3, plus the tan of 45 is 1, all over 1 minus root 3 times 1. Gives us root 3 plus 1 over 1 minus root 3. And you might remember from 20-1 that we never leave answers with radicals in the denominator. We rationalize, and there are two different types that you looked at. If the denominator was a single term, you just multiply top and bottom by whatever the radical part was. But when the denominator is a binomial like this one, we multiply top and bottom by the conjugate. The conjugate of 1 minus root 3 is 1 plus root 3. So what do we get now? So we're going to FOIL these out. Root 3 times 1 will be root 3. That's the front terms. The outer terms would be root 3 times root 3, which is 3. The inner terms, 1 times 1. The last terms, 1 times root 3. And on the bottom, 1 times 1 is 1. The outer products would be positive root 3. The inner products, negative root 3. Those cancel. That's why multiplying by the conjugate works, because those outer and inners, those radical terms cancel. So this gives us 3 plus 1, which is 4, plus 2 root 3, all over negative 2, which you can divide every term if you want by negative 2, and you'll get negative 2 minus root 3. There's our final simplified answer. That would be the exact value of the tangent of 105 degrees. So we can check this with our calculator in degree mode now. If we do the tangent of 105, the calculator will give it to you as a decimal. Well, that should be equal to what we found as an exact value. Negative 2 take away root 3 is the same decimal. So again, you should never get these wrong. You can always check them. Always. The difference is that by using the sum and difference identities, we're able to express our answers as exact values, not decimals that need to be rounded. Okay? So this next one, cos of 165. Again, you need to find two angles that add or subtract to get 165. 165 is not on the unit circle. And there may be more than one set that will work, but 120 plus 45 works. They're both on the unit circle. So now we're using the sum identity for cosine. The cosine of A plus B is cos A, cos B, minus sine A, sine B. Again, these are on the formula sheet. Don't have to memorize them. So 120 degrees, well, that has a reference angle of 60 degrees. It'll have the same two values as 60 degrees, except the x value would be negative. This would be negative a half, comma, positive root 3 over 2. So the cosine of 120 is negative 1/2. Times the cos of 45, which is root 2 over 2. Minus the sine of 120, which is positive root 3 over 2. Times the sine of 45, which is also root 2 over 2. So this gives us negative root 2 over 4, take away root 6 over 4, or negative root 2, take away root 6 all over 4. Which again, we can check in our calculator. We're in degree mode, so the cosine of 165 is that decimal. That's what we should get if we check the answer we got as an exact value. So negative root 2, take away root 6, all divided by 4. Same decimal. Should never get these wrong. Can always check them. Okay? And the last one, 11 pi on 12 is nowhere on the unit circle, but 8 pi on 12 and 3 pi on 12 are. We could say this is the same thing as the tangent of 8 pi on 12 plus 3 pi on 12. Because when you reduce those, 8 pi on 12, divide top and bottom by 4, you'll get 2 pi on 3. That's on the unit circle. 3 pi on 12, divide top and bottom by 3, you'll get pi on 4. That's on the unit circle. 2 pi on 3 is the same as 120 degrees. That's this part up here, where the tangent is negative root 3. So as we go down here, and we're using the sum identity for tangent, it'll be the tangent of 2 pi on 3 plus the tangent of pi on 4 all over 1 minus the product of those two. That's what the sum identity for tangent states. So the tangent of 2 pi on 3 is negative root 3. Tan of pi on 4 is 1, all over 1 minus the product of those two. So I'll write that as 1 minus root 3, all over 1 plus root 3. Right, the minus minus becomes a plus positive. And now to rationalize that, we would multiply top and bottom by the conjugate of the denominator, which is 1 minus root 3. So when we multiply these out, the front terms will be multiplied to get 1. The outer products would be negative root 3. Same thing with the inner products, negative root 3. The last, the negative times the negative is a positive. Root 3 times root 3 is 3. On the bottom, 1 times 1 is 1. The outer product's negative root 3. The inner, positive root 3. They cancel. That's why we multiply by the conjugate. So we're going to get 4 take away 2 root 3 all over negative 2, which again, we can divide everything by negative 2 and get negative 2 plus root 3 as our final answer. So to check it, this time we need to be in radian mode. Is that better? Okay, so we need to be in radian mode because we're doing the tangent of 11 pi on 12. Which is that decimal. Well, that should be equivalent to negative 2 plus root 3 if we did everything correct. And it is. Right, so we know our answer is correct. So those are the questions that you should work on for practice. Page 306, 307, questions 8 and 10. Not 8 through 10, just 8 and 10. Okay? That didn't hurt too bad, eh?